Artificial intelligence is usually described as a race for faster processors. But even the most powerful GPU becomes useless when it cannot receive data quickly enough. That is why one of the most important technologies in the AI boom is not the processor. The technology is called high bandwidth memory, or HBM. Conventional memory sits farther from the processor and moves data through relatively narrow connections. Multiple DRAM dies are stacked vertically and connected through microscopic channels passing through the silicon. The stack is placed close to the processor inside an advanced package. Thousands of connections allow enormous quantities of data to move. This matters because an AI processor repeatedly retrieves model parameters, training data and intermediate results. When memory cannot supply that information quickly enough, expensive computing units wait instead of calculating. The processor may be powerful, but the system performs only as quickly as its data can move. HBM acts like a wide conveyor belt feeding an enormous factory. A faster machine cannot increase output when the conveyor belt remains narrow. Generative AI transformed this specialized memory into strategic infrastructure. NVIDIA, AMD, and custom accelerator designers now require greater memory capacity, bandwidth, and power efficiency. Three major companies sit at the center of this race: SK, Hynix, Samsung Electrons. HBM requires advanced DRAM manufacturing, precise stacking through silicon connections, packaging, and thermal control. More layers increase capacity, but they also make heat, yield, and stability harder to manage. Memory suppliers must solve manufacturing, packaging, and cooling problems at the same time. SK Hynix helped establish HBM as a central AI technology and has built multiple generations for leading accelerator platforms. It completed HBM4 development in 2025 and later shipped HBM4E samples reaching 16 gigabits per second per pin. The company is also developing integrated cooling technology for future HBM packages. Samsung began commercial HBM4 shipments in February 2026 and later shipped HBM4E samples. Micron began high-volume shipments of a 36 gigabyte HBM4 product designed for NVIDIA Vera Rubin. Micron says it delivers more than 2.8 terabytes per second of bandwidth with better power efficiency than HBM3E. These advances show how memory is becoming part of the architecture rather than a replaceable commodity. Customers now work with suppliers years in advance to coordinate processors, memory, packaging, and cooling. That creates high technical barriers and makes qualified supply difficult to expand quickly. New fabrication lines require billions of dollars, specialized equipment, and long production cycles. Advanced packaging capacity can also limit how many complete AI processors reach the market. The memory bottleneck is therefore not only about speed. It is about capacity, yield, heat, energy use, packaging, and the ability to deliver at scale. As models grow larger, AI systems must move and reuse more data without allowing power consumption to rise uncontrollably. That pressure is pushing HBM toward deeper customization for individual processors and workloads. The companies controlling this memory may influence the cost, performance, and availability of future AI infrastructure. NVIDIA may design the computing engine. TSMC may manufacture the processor. But without high bandwidth memory feeding it, the engine cannot operate at full speed. The AI race is not only a race for more calculation, It is a race to move the right data to the right processor without delay. That is why memory has become one of the most valuable bottlenecks in artificial intelligence. And that is today's billion gem.